We're moving into our last unit, which is probability. What we're going to do today is we're going to look at an introduction to probability. When we're looking at the definition of a probability, the two main definitions that we come across are one, which is the proportion of times the outcome would occur over all of the possible events. Mathematically, this is what we're talking about. Whatever our event is, over all the possibilities. U stands for the universal, meaning all the possibilities. So the possibility that we want over all the possibilities. And that's our basic definition for a probability. So in this first situation, what we have is a bag and it contains 3 red marbles, a black marble, or 1 black marble, and 6 blue marbles. So that would be a total of 10 marbles. So our universal set would be 10. Now we're trying to figure out the probability of selecting a red. We know that there are 3 red out of the 10. So our answer is 3/10. For the second one, it says a blue. We know that there are 6 blue. So we go 6 over 10. Now with probability, you don't have to reduce it. You can if you want. So if you put 3/5, that would be correct. If you put 6/10, that would also be correct. The reason that we don't always reduce it is because sometimes it's helpful to know how many are actually in the universal set. So in this case, since there's 10 in the universal set, we know that there's 6 out of the 10. Even though the answer in the simplest form is 3/5, sometimes the original is actually more helpful. So either answer is going to be correct. You decide which answer you prefer. For letter C, a red or a black. We know that there are 3 red, there are 1 black, so that would be a total of 4 out of 10. Or if you want to reduce it, 2/5. Not a red. So what we're going to do is we're going to look at the complement. The complement is when we subtract. If there are 10 and we know that there are 3 red, that means if we subtract 3 from 10, we know that there are 7 that are not red out of 10. Now, a couple more probability laws. One of the most important ones that we know about probability is that probabilities are always in between 0 and 1. 1 we could think of as 100%. We can't have more than 100% of something. And we can't have a negative percent. So all the probabilities have to be in between these two values. The lowest probability ever is 0. The highest probability ever is 1. Now we're going to look at two different types of probability models, dependent and independent. Dependent is when one event is affected by another event. Independent probabilities are when one event is not affected by another event. Now we'll see in these two different cases. We're going to look at dice and cards. We're going to first look at cards. Cards would be dependent events. The reason that it's dependent events is when you pick one card, we no longer have 52 in the deck, we now have 51 in the deck. So our probability changes from 52 to 51. Whenever our probability changes, that means it's a dependent event. So looking at our card example, what we have is the probability of picking 2 kings. So if you know a deck of cards, there are 4 kings out of 52. That would be picking the first card. Now we want 2 kings. So that means that if we have 1 king in our hand, there are now 3 kings left. So we only have a choice of picking 3 now. Now, as I said before, if you have 1 card in your hand, you no longer have 52, you have 51. So this is our setup. If we multiply those, 4 times 3 is 12. 52 times 51 is 2652. And that right there is our answer. I'm not going to reduce it. I'm just going to leave it how it is. Now, with our next one, we have a king and then a jack. So our first card is a king, just like the last one, 4 out of 52. And then our second one is a jack. There's 4 jacks. Remember, we took a king out of the deck. We didn't take a jack, so there's still 4 jacks. But instead of 52 cards, there's 51 because we have a king in our hand. So this probability is 16 out of 26. Now, 2 hearts. There are 13 hearts in a deck. So we're going to go 13 out of 52. Now, if we have a heart in our hand, there are no longer 13 hearts. There are now 12 hearts. We no longer have 52 in our hand. We now have 51 in our hand. So 13 times 12 is 156. And once again, 26, 52. Now with this next one, this is probably the most difficult because it says 1 queen. There's 2 reasons why this is difficult. All it tells us is 1 queen, so we know 4 out of 52. The problem is it doesn't tell us what the other card is. Now, if we only have 1 queen, then that means the other card is not a queen. So that's going back to what we did on the last one. There are 52 cards, and one of them, and we know that there are 4 queens, and that means there are 48 cards that are not queens. So we have 48 out of 51. The problem is that we're not done yet because we want 1 queen and it doesn't tell us what our first card is. Now, in letter A, we know our first card is a king. In letter B, we know our first card is a king. In letter C, since we have 2 hearts, we know that the first one has to be a heart. Now with letter D, we know that we have 1 queen, but we don't know if the first one is the queen or if the second one is the queen. So we actually have 2 possibilities. So we're going to multiply this by 2 because either the first one is the queen, the second one's not the queen. This is a little signature for not. Or the second one could not be a queen and, sorry, the first one not being a queen and the second one is a queen. So it could be this possibility or this possibility. There are 2 possibilities, so we times it by 2. 2 times 4 times 48 gives us 384 over 26.